So we have a test coming up for chapter 4. And your quiz is going to be these problems. And I would recommend right now that you listen to me. First thing you ought to do is you ought to turn in your workbook to the extra notes page for, I don't know, you could go to the end of the chapter if you wanted. You could go to this section today that we're covering, which is 4.5. Either one, okay? And I would do the quiz on this page. Now, write every problem. Don't just write the answers. Write the problems. Show your work. Before you begin, I want you to do something else. I actually want you, for each of the quiz problems, I want you to do the problem, but I actually want you to write the name of the law of exponent or the names of the laws of exponents that you are applying to do this problem. There are 25 problems on every test. And this is not the whole quiz. I'm going to finish writing it after I explain this to you. There are 25 problems on every test. On this test, there are 8 laws of exponent problems. Think about that for a minute. 8 times 3 is 24, which means that 1/3 almost of this entire test is just laws of exponent problems. There are 2 scientific notation problems. So 10 out of the 25 problems we're going to put on the boards today, an example of each type of problem that's on the test, and we're going to practice those. So this is actually the first half of your review for the test, okay? So we're not going to do the review all in one day. We're doing part of it as a quiz today. So your attendance here gives you points for attendance and points for quiz. Go ahead and begin this quiz when you are there, and like I say, show your work, write the problem, write the answer, and write what law or laws of exponents you used to simplify these problems. There will be 3 more problems down on this board, down here. Okay, for those of you in YouTube land, you'll want to write all these down, and you will need to do this quiz, and you'll need to submit a photo of your quiz completed in an email to myself or Bailey Zinter. That will be provided for you, as it always is, her email. If you write me an email telling me you're going to be sick. But basically, if you're not here today, you got to do this quiz to get credit for it. Okay, you can pause. Got this. Don't get any wrong. So 5 to the negative 2 or 5 to the negative 6, this is the product rule. Okay, that's the one that you should have identified. If you chose to use the negative exponent rule and bring that to the bottom first, you could have done it that way, but this is a pretty easy product rule approach. You should not multiply 5 times 5 and say it's 25. That is not a 5. 5 to the negative 2 is really 1 over 5 to the second, which is 1/25. 5 to the 6 is 5 times 5 times 5 times 5 times 5 times 5, which is a far cry from 5. It's a big number. I don't know what it is. It's 125 times 125. But the bottom line is that that's not 5 times 5. That's the number one mistake the students make. They multiply 5 times 5 and say it's 25. This is 5 to the negative 2 plus 6, which makes 5 to the 4th. Say woo if you got it right. Woo. Good job. 5 to the negative 3rd. This is the negative exponent rule. That's what you should have identified as the one that you worked with. This ends up being 1 over 5 to the 3rd, which is 1 over 5 times 5 times 5, which equals 1 over 125. We would accept either one of these as correct answers. Say woo if you got it right. Woo. But taking the test, okay, please look up here. Will they have this and this in their multiple choice? Never. That would be a double jeopardy, okay? You cannot do that. It's one or the other. But they could have this, so be prepared to multiply it out if needed. Cool? Okay. X times x to the negative 2. This is going to be both the product rule and the negative exponent rule. Combination problem here, okay? Both of them. So the product rule says it's x to the 1 plus negative 2, right? Which makes x to the negative 1, which equals 1 over x to the 1, which equals 1 over x. This is also, we're going to say, and the 1 rule. So use 3 rules in one there, okay? Because the 1 rule is x to the 1. Say woo if you got it right. A few less woos there. A couple mistakes. Make sure you get that right, okay? Remember, this is a 1. Because they have the same base, you get to add them. 1 plus negative 2 makes negative 1. Anything negative goes down and becomes positive, right? What's the answer to this one? 1. The answer to this one is 1. This is just the 0 rule, okay? Hopefully that's all you had to do there was understand that everything in the parentheses receives the power. If the parentheses is all surrounded by a 0 degree, then everything is 1. If you needed to take this and say, well, that's 3 to the 1 times 0, and x to the 3 times 0, that would give you 3 to the 0 over x to the 0. 3 to the 0 is 1, x to the 0 is 1, 1 times 1 is 1. You could have gone through that whole sequence of thought process there, but just understanding if you take an entire parentheses to the 0 power, then everything is going to be to the 0 power, and which means everything is equal to 1. So it's just 1, okay? This right here is a brilliant example of the quotient rule. Quotient rule says it's got the same base being divided. I can subtract this. This makes p to the 2 minus negative 7, which is p to the 2 plus 7, which is p to the 9th. Give me a loud woo if you got it right.
Ooh.
Good. Gentile. Ooh. You got the loud and the elongated woo there, okay? All right. Okay. Could you have done this differently? Sure. You could have said that this equals p to the 2nd times p to the 7th. Why? Because you could have applied the negative exponent rule and brought it up top, which then you would have the product rule and say that's p to the 2 plus 7, which makes p to the 9th. There's different ways to do these problems, right? Same thing back here. You could have brought that x to the negative 2 downstairs and done it that way, but I'm doing it the way that I want to say it's easiest, okay? That isn't always easiest in your mind, and that's okay. So I would say more, I'm doing it the way that is what I consider the path of least resistance, okay? That isn't always the easiest for you, but it is the path of least resistance in terms of the efficiency of the problem, okay? This is also the quotient rule, okay? This is also the quotient rule. And both of these have negative exponents in them, but the negative exponents are taken care of by the quotient rule because this is x to the negative 4 minus negative 8, which makes x to the negative 4 plus 8, which makes x to the 4th. Say woo if you got it right. Okay. You could have applied the negative exponent rule and immediately said that's x to the 8th over x to the 4th, swapping places because they're both negative exponents, which then you could say that's x to the 8 minus 4, which would have been x to the 4th as well. This problem right here is the power rule. It says that everything in the parentheses receives the power. Please look at this. This is going to be negative 3 to the 1 times 4 and a to the 2 times 4, which makes negative 3 to the 4th, a to the 8th. Now, if you forgot to bring the 4 to the 3, that's something you've got to be on top of for the test because everything in the parentheses receives the power, including the coefficient. But this is not the final answer on a test. Tell me something. All these problems, if they didn't have a direction, and on the test they do have a direction, and the direction will be what I'm about to ask you, rather than reveal it to you, if none of these had a direction, what would they be? A solve or a simplify problem? Because no equal sign. Very good. So the directive that you're going to be given on the test is to simplify these. If you were asked to simplify this, to simplify means to get it in its simplest form. This answer, therefore, is 3 to the 4th, a to the 8th. You could say, why, Brother Rich? Well, isn't negative 3 to the 4th negative 3 times negative 3 times negative 3 times negative 3? Well, it is. Okay? And you could say, well, wait a minute, Brother Rich. I thought the negative comes down in the answer, and it's just 3 to the 4th. Well, the 4th is being applied to that negative 3. So this really is negative 3 to the 4th. Okay? Which is negative 3 times negative 3 times negative 3 times negative 3. Well, these two negatives make a what?
Positive.
And these two negatives make a what?
Positive.
And that makes the answer a positive answer. And a positive answer is definitely considered more simplified than a negative answer. And so you got to remember that. That's a really powerful thing we wanted to review before we take the test. Okay? Yes?
Didn't you also make that simpler?
multiply 3 times 3 is 9 times 3 is 27 times 3 is 81? You could, but they may not do that. They may leave it as 3 and then make it a positive 3 because since there's to the 4th power. Please look up here. It's a great question. So you could say, ultimately you're asking, hey, is this 81 a to the 4th? Quite possibly they could do that.
8.
Sorry, what was that?
8 to the 8.
Huh?
8 to the 8.
Oh, sorry, 8. Sorry, my bad. Got myself a little excited there. 8 to the 8th. Woo, let's put an 8 there. Okay? Now, so we say or. That would be acceptable, but this is probably going to be the answer on a test. However, listen, what if this was to the 3rd power? The negative would still be there. That's the thing I need you to understand, is an even exponent will make that negative become positive. An odd exponent will leave it negative. Okay? That's the main precept that I want you to be on top of for the test. Okay? Let's come down to this board, do these ones real quick. Okay? This is going to end up being times 3, times 3, times 3, which makes x to the 15th, y to the 15th, right? Because this distributes to all these over z to the 24th. Say woo if you got it right.
Woo.
Okay? Write this in scientific notation. Decimals here. Here we go, loop-de-low, right? We ended up with 5.42 times 10 to the, we moved it 4 places. The original number was bigger than 1. Say woo if you got it right.
Woo.
Hard or easy? Easy. Okay? And this one, again, we got to remember we take numbers and divide them by numbers. So we take 7.36 and divide it by 2.3. What did you get with that?
3.2.
3.2. Is that number in scientific notation?
Yes. Yes.
You sure?
Yes.
Positive?
Positive.
Yeah. Don't follow my facial expressions. Follow your mind. Is that in scientific notation?
Yes.
It is, because it only has 1 digit to the left of the decimal. Times comes along for the answer. 10 to the 6th, and basically divided by 10 to the negative 8 is 10 to the 6th minus negative 8, which makes 10 to the 6th plus 8, which makes this times 10 to the 14th. Say woo if you got it right. Okay, do you need to convert that to scientific notation? No, because it's already in scientific notation, right? We had some other problems in our homework where we had 2 digits to the left of the decimal, or only a 0 to the left of the decimal, and we had to get it in scientific notation. This one was good to go. Okay? That reviews 10 problems of the 25 you have on the test. That wraps up your quiz for today. We're going to jump into section 3.5. Multiplication of polynomials. Jump with me there, please. Can I erase these boards? Y'all good? Okay. You're on. Here we go. So if you look in the upper right-hand corner, we were talking about polynomials and how to multiply them today. Something kind of cool here. I want to remind you of an old principle called the commutative law. You'll notice right here in the middle of the page we have this 2 times 4 times 3. 2 times 4 times 3 equals 3 times 2 times 4. Okay, please look up here. I have a 2, I have a 3, I have a 4. I rearrange them, I still have a 2, I have a 3, I have a 4. But because they're being multiplied, we learned a long time ago in the commutative law, the commute means to move, right? So even if everything's being multiplied, I can rearrange it and it still will give me the same answer if they're all being multiplied. Agreed? So, what is 2 times 4? 8. And 8 times 3? 24. What is 3 times 2? What's 6 times 4? They are the same. Yep, they are the same. There's no doubt about that. They are equal. Okay? So you can write that just underneath those two things. It's a reminder of the commutative law. The commutative law is going to come into play here for us. Okay? So there are 4 types of multiplication of polynomials. There's the monomial times the monomial times any polynomial, the binomial times the binomial, and the any polynomial times any polynomial. And we're going to talk about each of those 4. But it says up here, there are 4 types, but they all come back to mono times mono. If you learn the mono times mono and you understand how to do it, you know how to do all the others. So this is where our emphasis needs to be placed right now, the monomial times the monomial. And we're going to call them by their shortened names, mono times mono, bi times bi, mono times any poly, stuff like that, okay? All right, monomial times mono. I can't say it. Monomial times monomial. Mono times mono. So this is what guides us here. We're going to take big numbers and put them with big numbers. We're going to take x's, put them with x's, y's with y's, etc. So we're going to do this first problem here. How many terms are in this parentheses? How many? In this parentheses? One. And in this parentheses? So what you're going to write here is you're going to write 1 times 1 equals what? 1. So you're going to write 1 times 1 equals 1. 1 term times 1 term equals 1 term. Okay? You good? Okay. Read that problem to me. Logan, read it to me, my man.
2x to the 2 power, y, parentheses, and then negative 4x, y to the 3 power.
Okay, all eyes up here. Don't look down, don't write. I want you to do this with me. So everything is being multiplied, okay? I want to ask you a question. What's being written in between the 2 and the x squared? Say it loud. Literally, what is being written in between the 2 and the x squared? Literally. Literally. Nothing. Nothing. Right? Nothing's being written in between them. Literally. Okay? And what does that mean? When nothing is written between two entities in math, what does that mean? It means you multiply. Right. Right. Okay? So, what is being written in between the 2 and the x squared? Nothing. What's being written between the x squared and the y? Nothing. All eyes up here. You guys are looking down. Don't write. What's being written in between the parentheses? Nothing. Between the negative 4 and the x? Nothing. In between the x and the y to the third? Nothing. So what's taking place between all of them? Multiplication. And if everything's being multiplied, we can do what?
Rearrange it.
We can rearrange it. That's right. And so I'm telling you, when I talk about this right here, numbers with numbers, x's with x's, y's with y's, I'm talking about the commutative law here. 2 and negative 4. X squared and x. Y and y to the third. Look up here. There's the 2, there's the negative 4. I put my numbers with each other, numbers with numbers. X squared with x. I put my x's with my x's. Y to the third. I put my y's with my y's. Is everything here accounted for up here?
Yes.
Am I missing anything down here that was up here? Nope. So 2 times negative 4 makes what? Negative 8. X to the second times x. Well, we learned the laws of exponents for a fetch and reason. We're going to use them. X squared times x makes x to the third. Y times y to the third makes y to the fourth. Okay, y times y to the third, not y times y. Y times y to the third makes y to the fourth. And that's my answer. And I'm done. You guys good? Okay. Hard or easy? I think it's pretty good. I think you can handle this.
How do we
Okay?
get the 4 again on the y?
What's that?
How do we get the 4 again on the y?
Because, look up here, we have y times y to the third, right? Because nothing's written in between them, they're being multiplied, right? And this is y to the first. And when I have things of the same base being multiplied, I get to add their exponents, laws of exponents, which makes y to the fourth, right? It's a great question you just asked. I love that question. Okay? Same thing with x squared x. Look up here. X squared x is the same as x squared times x to the first, which is x to the 2 plus 1, which makes x to the third, right? Okay? Very good. Okay, so now, what are you going to do? Well, you're going to do these 3 problems on your own. Okay? But what I want you to do in your workbooks is follow the same pattern we just did on that board. I want you to look up here. I want you to take negative 2 times negative 10 times negative 3, and then y to the fifth, y to the fourth, y to the third. I want you to put your numbers with your numbers, and your y's with your y's, your a's with your a's, your x's with your x's, right? On all these problems. You guys cool? And then combine it all and do it. Okay? We're going to pause, give you a few minutes to do this. Go. Numbers with numbers. This is the way I would like to see you do this problem. You take negative 2 times negative 10 times negative 3, and y to the fifth, y to the fourth, y to the third. And you end up here with negative, 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 make a negative what? 60. Very good. And y to the 5 plus 4 plus 3 makes y to the 12. Say woo if you got it right. Ooh, very good. Right? Right? Y to the 5 plus 4 plus 3, right? Remember that? Y to the 5 plus 4 plus 3 makes y to the 12. Okay, this one, again, 10 times 2, a to the second makes 20, a to the fourth. Say woo if you got it right. Ooh, good job. Okay? And then over here, you have 0.3 times negative 0.8, which you put in a calculator, and you're going to get negative 0.24. and you have x to the 4th and x to the 4th, which makes x to the 4 plus 4, which makes x to the...
Well, it's,
One of them's a 6.
6.
Which one's the 6th?
Second one.
This one? 6th?
Yeah.
Oh, I'm sorry. Okay, and that'll be 6. That makes more sense. And 4, did you say 4 times 6 is 24? Don't do that, right? It's 4 plus 6 makes x to the 10th. Say woo if you got it right. Okay. All right, I got a question for you. Raise your hand if you got 100% on those 3 problems. Raise your hand if you got 100% on those 3 problems. Raise them high. Come on, come on, come on. High. Okay? That's the majority of you. Now, if you didn't get them all right, okay, do you understand what you did wrong? Do you understand what you did wrong? Okay? So, relatively speaking, hard or easy? What do you think about this material? Okay. Here's the deal. Okay? Everything we do in multiplication of polynomials comes back to multiplying monos times monos. If you know how to do this, you know how to do it all. But from here on out, the other 3 are about being thorough and organized. So I want you to write right here where it says 4 times, but they all come back to mono times mono. I want you to write right here, be thorough and organized. Be thorough and organized. Now in the last class, man, they were having a debate about how to spell thorough. They were just, how do we do it? Okay, it just doesn't matter because I'm not going to grade your workbook. But remember Thor, the god of thunder? Okay, Thor, Thor, and Ough for dough, right? Because he got kind of fat in the end, you know what I'm talking about? Yeah. Thor the dough boy. Thor, Thorough, okay? That's good? Okay. Let's go to the next page. Let's go to the next page. Oh, the next one. Mono times any poly. Means you're going to have a monomial times something besides a monomial. Shows up there in parentheses. You can have, like, up there in the parentheses, right? You got a bi, a tri, or 4 or more terms. So the any poly is a binomial or something greater, okay? Look up here. You have a monomial times a binomial. Here you have a monomial times a polynomial. How many terms right here? How many terms right here? 1. Okay, so right here I want you to write 1, and then you're going to put times. How many terms right here? 2. So you're going to write 1 times 2. What does 1 times 2 equal?
4. 2.
This is on YouTube. This is on YouTube.
Proving every day that you are Homo sapiens. Yes. Okay? Humans. It's always fun. You should try this sometime when you have a child. You say, "You're a Homo sapien." They're like, "No, I'm not." Like, okay, you're an alien. All right. So it's always funny when you tell your kids something they don't understand. Like, "No." I'm like, okay. All right. So 1 times 2 equals 2. How many terms here?
1.
How many terms in here?
4.
So you're going to write 1 times 4 equals, and what does it equal?
5.
Bro, come on, we're on freaking YouTube here. You got it. Chill. 1 times 4 equals 4. All right. So let's do this first one together. Now, notice that, before we come to the board here, notice that there is a process here where you say, hey, I got a mono times a term, plus or minus a term, plus or minus a term, etc. And that's going to give me a mono times a term, plus a mono times a term, plus a mono times a term. And always we're going to write plus in between here because the sign before the term is going to go inside the parentheses with it. And I'll show you what that means. So we have negative 4x squared, right? Negative 4x squared times what?
X squared minus x.
X squared minus x. Thank you. So watch what I do. We're going to take negative 4x squared and multiply it times x squared, right? This has to go to here, and then it has to go to here. And I'm going to have plus, always a plus there, negative 4x squared times negative x, right? Negative 4x squared times the second term, negative x. Think about it. I have a mono times a mono. I have a mono times a mono. You just told me that monos times monos was pretty easy. But now you just have more of them than you did in the first set of problems. Everything comes back to being a mono times a mono. It's just now I have a mono times 2 terms, so I'm going to have 2 mono times monos. So I take negative 4 and I have x squared, x squared. Here I have negative 4 and negative 1, right? Here I have negative 4 and 1, because that's a 1 right there. So negative 4 and 1 makes negative 4, x squared and x squared makes x to the 4th. Here I have negative 4 times negative 1 and x squared times x. Negative 4 and negative 1 make positive 4. X squared and x make x to the, x to the, x to the. Are you going to end this for me? X squared times x makes x to the. This is getting scary today.
Sorry, I wasn't
Is this x to the 1?
Yeah.
And that's x to the 2 plus 1, which makes x to the 3rd, right?
Yes.
X squared was x to the 2 plus 2, which makes x to the 4th. This is your final answer. Hard or easy?
It's easy.
It's relatively easy. If you think about it all being monos times monos. So now I want you to do this problem. So let's go ahead and pause. I'll give you a minute. Go ahead and do that problem. You done? What? What are you doing? Watching me play basketball?
What's your brother marker?
Are you recording? Negative 4x times 2x to the 3rd, right? That has to go to here. Plus, always plus, negative 4x times what? Negative 6x squared. Plus, always plus, that has to go to here, down to here. I got negative 4x times negative 5x plus negative 4x times 1. I have 1, 2, 3, 4 mono times monos. But still just a monomial times a monomial. But if you understand how to do that, you understand how to do all this. But you got to be thorough and organized because it's kind of cumbersome with this many. Now I can take this and I can say that's negative 4 times 2 because I can rearrange the mono times the mono. Cannot rearrange this with these, but I can rearrange this in here, right? Negative 4, 2, right? Numbers with numbers, x's with x's, x and x to the 3rd. This makes what? Negative 8x to the 4th. Very good. This right here is negative 4 times negative 6 and x squared. This makes positive 24, x to the what? 3rd. Very good. This has negative 4 times negative 5 and x. What does that make? Plus what?
20.
20.
X squared.
X squared. Very good, Gentile. And I have negative 4 and 1 times x, which just makes negative 4x. Say woo if you got it right.
Woo.
Good. Okay.
Well,
Let's pause for a second. Not this. Them.
Okay.
You still playing? Okay. All eyes up here, please. Drop your pens and pencils. This is imperative. Look up here. Is multiplying a monomial times a monomial hard?
no.
Is multiplying a mono times a mono hard?
No.
Okay? But we're doing it 4 times. If you're not willing, don't write, if you're not willing to write this step and this step to get to this answer, you're not interested in being successful. And that's life. I got people all the time. Brother Rich, I want to make money. Brother Rich, how did you have success running a business? Brother Rich, I want to be rich someday. Well, if your mother names you Rich, then, you know, it's kind of inevitable. But listen, the price to pay for success is usually like this. It's just work. And people tell me all the time, Brother Rich, I want to be successful. I want to be rich. And I'm like, do you really? Because sometimes they really don't. Because they really don't want to work. They want the goods, but they don't want to do the work. This is the price to pay to get the right answer on this problem. If you're trying to do it in your head, you're going to screw it up. Got me? Okay, we got to go to the next section. Let's go to the next page. The next type of multiplication of polynomial, once again, just an extension of monos times monos, is the bi times bi, the binomial times binomial. Okay? How many people ever learned the acronym FOIL? What does it stand for?
First outside inside.
Okay, all right, Grace. We got to move this table back. You're going to have to slide back here for a second. Everybody stand up! Hurry! Stand up! Okay. Stand. Don't be a punk. Stand up. Okay? All right. Now, this old body of mine is feeling it today. Oh, baby. Oh, yeah. Okay? Spotlight. Thank you. Okay? Everybody put your hands in the air. Okay, it's a non-optional activity, meaning you have to do it. Okay, let's see your palm tree. Sway. Sway it. Sway. Come on. You're what? It's been a long day. It's only 11 a.m., huh? Okay, listen. Sway it. All right, now we're gonna do. Get those hands up. We're gonna do the foil dance. Okay. Now, when I say first, you're gonna hip thrust to your left. Okay. When I say outside, you know where that is. That's back here. When I say inside, it's a forward thrust, and when I say last, it's to your right. Okay. Ready? Sway it. Sway it. First, outside, inside, last. First, outside, inside, last. Okay, that is the foil dance. Now, if you're at home doing your homework and you're like, I can't remember how to do this, just stand up and do that. See what your roommates have to say about you and your homework. Okay? All right. What's the first problem on the board there? X plus 3 times x plus 7? Mm-hmm. Okay. Again, we still got a fair amount to do, and I want to make sure we have enough time to do it. So look up here. X plus 3 times x minus 7.
Plus 7.
Plus 7.
Yes, it's supposed to be a minus, but we put a plus on this. So that's a typo, but we're going to do it this way because it's in your book this way. Okay, please listen. This right here tells you everything in the first parentheses goes to everything in the first parentheses. For those of you who learned FOIL, please, I'm going to help you right now. I'm going to help y'all, okay? If you like FOIL and you want to stick with it, you sure can. But here's what I want to teach you. F-O-I-L. I hate acronyms because they're confusing a lot of times. This stands for first, which means the first term in each parentheses. X times X. Outside, instead of dealing with each parentheses, we're now looking at the entire thing. We got X and 7 are on the outsides. X times 7. I guess we put a plus in between each one because Brother Rich taught us to put a plus in between each one. Inside, 3 and x. Okay? And the last term in each parentheses is plus 3 and 7. But here's what I want to teach you. If you don't know FOIL, or FOIL confuses you, where's the outside? What's the inside? What's last? All this stuff. Okay? Then you can simply say everything in this parentheses has to go to everything in this parentheses. Meaning x has to go to here and to here. And 3 has to go to here and to here, okay? And so ultimately, please watch this. I have x times x plus 7. You don't need to write that step. Plus 3 times x plus 7. You understand what I'm doing here? I'm taking x times this parentheses and 3 times this parentheses, which if you want to go straight to this step, you can, which is going to be x times x plus x times 7 plus 3 times x plus 3 times 7. Notice these and these are the... So you could do it either way. Everything in the first parentheses goes to everything in the second parentheses. Please look up here. You were asked the question as you were in all the other sections. How many terms are in this parentheses? How many?
2.
How many in this one?
2.
And they're being? So I have 2 times 2 equals?
4.
You want to say 5? 6?
7.
There you go. 2 times 2 equals 4. All right. Check it out. Okay. I have 4 mono times monos. X times x. Everybody help me. X squared. X times 7. We put the number in front of the x. What do we get?
8x.
7x. Come on, bro. Okay. Hurry. We got to hurry. What's 3 times x? 3x. And 3 times 7? 21. And it says right here, middle terms often combine. Okay, these are like terms. What does that make? 7x and 3x makes? 10x plus 21. Okay, we cool?
Yep.
Okay, real quick. You got about 1 minute. Rip those 3 out. Go. We're going to pause on our camera here. You've done some of them. Please look up here. Everything in the first parentheses has to go to everything in the second parentheses. I'm going to end here with 2x times 2x plus 2x times 5, right? 2x times 2x, 2x times 5, plus 5 times 2x plus 5 times 5. I have 1, 2, 3, 4 mono times monos. Numbers go with numbers. 2 times 2 is 4. X times x is x squared. Numbers go with numbers. 2 times 5 is 10. I have x. Numbers go with numbers. 5 times 2 is 10. I have an x. And 5 times 5 is 25. My middle terms combined. What's my final answer? 4x squared plus? 20x plus 25. Going to the next. Say, well, you got it right. Woo. Good. Okay, this one here. I got numbers with numbers. 3 times 6 plus 3 times 2x plus x times 6 plus x times 2x. I have 1, 2, 3, 4 monos times monos. 3 times 6 is 18. 3 times 2x is 6x. X times 6, what do we call that? We put the number in front of the variable, 6x. And then numbers with numbers, we got 2 and 1 makes 2, and x makes x squared. This ends up being, we combine the middle terms, 18 plus 12x plus 2x squared. Can I tell you? The answer in the back of the book and the answer on the test will probably be written in descending order, something we learned last time. And so it would probably be written like this. These two answers are the same. They will not have both, but this will probably be the one that they write. Okay? Say woo if you got this right. Woo. Okay? Last one. Okay? I'm going to end up here with x times 2x plus x times negative 2, right? X times 2x, x times negative 2, plus negative 5 times 2x. Notice how I always write plus in between. Take my sign with my term. Plus negative 5 times negative 2. In the end here, I get 2x squared minus 2x minus 10x plus 10. And I end up with 2x squared minus 12x plus 10. Say woo if you got it right. Good. Okay? All right, let's go to our final page. Quickly. We've got to hurry. And we actually have another section to cover. And you're like, what? But the other section we've covered, I just have to give you a quick note on it, and you'll be solid and good to go. Can't get this to turn. Here we go. All right. Our final multiplication of polynomials is the any poly times any poly. Can you see that everything is just monos times monos, but just more and more and more of it, right? Okay, really quick, help me. How many terms are in this parentheses quickly? How many in this one? So we have 2 times 3 equals 6, okay? How many terms are here?
3.
And how many in here?
3.
And in between, you're multiplying 3 times 3 equals? So you're going to have 6 monos times monos and 9 monos times monos in this one. Look at these two on the board here, please, quickly. We'll do these rapidly. Please look up here. Now, I do this a little bit differently, and I would pay attention to what I do. I'm going to have x squared times 2x squared minus 5x plus 1. I'm going to say, I'm actually going to say minus 6 times 2x squared minus 5x plus 1. Do you see what I did? I took this term and multiplied it times that parentheses, and this term and multiplied it times that parentheses. Now I'm going to say x squared times 2x squared plus x squared times negative 5x plus x squared times 1 plus negative 6 times 2x squared plus negative 6 times negative 5x plus negative 6 times 1. In the end here, I get 2x to the 4th minus 5x to the 3rd. And again, you can rearrange these. If it helps you to say negative 5 and x squared x, you can do that before you bring the answer down. Plus x squared, you're going to have minus 12x squared plus 30x. That's these right here. And then the last one is minus 6. The only terms that combined were these two. And you end up with 2x to the 4th minus 5x to the 3rd. Minus 11x squared plus 30x and minus 6. Okay, last one right here. Okay, let's do this together. Okay, I'm going to have x times x minus y plus 1. I'm going to have plus y times x minus y plus 1. And I'm going to have minus 1 times x minus y plus 1. Y'all agree? See what I did? I took x multiplied times this parentheses, y times this parentheses, negative 1 times that parentheses. When we get done doing this problem, we're going to continue to film the next portion. If you want to watch the rest of that on YouTube, you can, or you can stick around and watch it. But we're going to film it. You guys cool with that? Okay, so let's just finish this problem. Then if you need to go, you can go. If you want to stay, you can stay. But if you go, you got to watch the rest of this on YouTube, okay? Kind of find the end. It'd be like maybe 5 minutes of discussion. Please look up here. This is going to be x times x plus x times negative y plus x times 1. That's what that makes. Understood? And that's going to give you x squared minus xy plus x. Agreed? And then this right here, look at this, right here is going to give me plus y times x plus y times negative y, that's a y there, and plus y times 1. And that's going to give me plus xy and minus y squared and plus y. Notice what I did here. I took that yx and called it an xy. Why would I do that? Why would I do that? Okay, well, if I don't, I'm not going to see that these are like terms. This is going to look like a yx, that's going to look like an xy, and they're not going to look like terms. Do you agree? Okay, and so we can always put things in alphabetical order when we gather them together. And then finally, this one here is going to be, just really quick here, we're going to have plus negative 1 times x plus negative 1 times negative y and plus negative 1 times 1, okay? This ends up being over here, negative 1 times x is going to make negative x, negative 1 times negative y is plus y, and negative 1 times 1 makes negative 1. Got a lot of like terms here, please look up here. Negative xy and positive xy are going to go bye-bye. Positive x and negative x are going to go bye-bye. Okay, positive y and positive y are going to combine, so I get x squared minus y squared plus 2y minus 1 is my final answer for that. And that's the any poly times any poly. So the bottom line is this. You have to be thorough and organized as you get more and more and more of these, all right? So what we're going to do right now, you guys are cool to jam. If you want to, if you can stick around, you want to watch 4.6, you're welcome to. Okay? I'm just going to teach you 4.6. You have both assignments tonight. Okay? So I'm going to flop the page, erase the boards, and just try not to walk in front of Grace, and quietly exit if you could, okay? Okay, section 6. So everything in section 6 is still a multiplication of polynomials, but it's the binomial times the binomial. But they're all kind of special scenarios. Grace, would you read the first problem to me?
The verses or the...
And by the way, guys, I'm going to take a few minutes to do this, so if you got to jam, just jam. Go ahead and read x plus 7. What do we got?
Okay, x plus 7 squared.
Does it equal x squared plus 7 squared? All right, so when we learned the laws of exponents, we learned the power rule. And the power rule taught us that everything in the parentheses receives the power. But if you go back to your laws of exponent chart, it says that law only applies to monomials, and that's a binomial. So there are no shortcuts. There are no shortcuts for bis and tris and all the other polys, okay? Only for monos, only for the monos when it comes to the power rule, okay? And so what ends up here, these do not equal each other because since we can't take a shortcut, look at this, and this is gonna happen over and over and over again on the test and the homework, we have to say, what? X plus 7 squared is x plus 7 times x plus 7. So we just have to go and do all the math with this, which is gonna be x times x, plus x times 7, plus 7 times x, plus 7 times 7. X times x is x squared, x times 7 is 7x, 7 times x is also 7x, and this makes 49. These middle terms double each other up and combine, meaning that makes x squared plus 14x plus 49. Notice that does not equal x squared plus 7 squared, right? Because that would eliminate the middle terms. So nope, that doesn't work. So when we see this type of a problem in our homework, we cannot just take a shortcut. We have to go the long way to school and do the actual problem. These problems where these two parentheses are the same, these are called, you're going to fill that in right now, these are called binomial squares. So I'm going to write that answer down right now. They're called binomial squared, okay? And so when you have the exact same binomial, it's a binomial square, which makes kind of sense. What happens to the middle terms? You want to answer that, okay? They combine / double, okay? So like 7x plus 7x, that doubles to 14x, but they always combine. You guys cool? Okay, so the next problem up there is 3 squared plus 4 squared. Let's go ahead and quickly do that. 3 squared plus 4 squared. 3 squared plus 4 squared. So if we get rid of the whole variable thing and just do it all with numbers, does that equal 3 plus 4 squared? Well, it's not going to. 3 squared is what? Help me. 9, and 4 squared is 16, and 9 plus 16 makes 25. 3 plus 4 squared, we have to do what's in the parentheses first, makes 7, and 7 squared makes 49. And so I guess what we're trying to show you here, if we return back this, those don't equal each other. If we come back to this, it makes sense that you can't just apply the square to each thing in the parentheses, okay? Come back over here, look at, if we applied the square to each thing in the parentheses, we would have 3 squared plus 4 squared, and they would be the same. But they're not. And so we just proved that that doesn't work when we just do it numerically. That's the whole purpose of that. The last thing we'll share with you is this right here. I want you to write down, I'm going to erase this board over here. These are called conjugates. Okay, so I'll write that real quick. These are called conjugates. All right, so let me spell that for you. Conjugates. And what happens to the middle terms? Okay, they cancel each other out. They cancel each other out. All right, so this is a unique kind of binomial. If you look at it, we have x plus 7 times x minus 7. Okay, really quick. X plus 7 times x minus 7. X plus 7 times x minus 7. So this binomial is the exact same binomial, except the two terms are being added in one parentheses and subtracted in the other, but the terms are identical, other than the fact that they're being added and subtracted. So when we multiply this, okay, we're going to get x times x plus x times negative 7 plus 7 times x plus 7 times negative 7. We're not learning anything new here. We know how to multiply a by times a by, but what we're learning is how do we handle certain binomials times binomials. Well, x times x is x squared. This is minus 7x. This is plus 7x. And this becomes minus 49. Well, what happened to these middle terms? Yeah, they cancel each other out. And they always cancel each other out. That ends up being x squared minus 49. These are called conjugates when the parentheses are exactly the same, but one's being added, one's being subtracted. And the middle terms cancel each other out. So if we have 2p minus 5 and 2p plus 5, okay, let's do that right here. 2p minus 5 times 2p plus 5. One of the things we can do here, it's kind of fun, is we can say, hey, 2p times 2p is 4p squared, and negative 5 times positive 5 is minus 25, and that's my answer, and I'm done because the middle terms are going to cancel out. If we go through this and just do it the long way, we're going to have 2p times 2p, and we're going to have plus 2p times 5, and we're going to have plus negative 5 times 2p, and we're going to have plus negative 5 times 5. What ends up happening here, 2 times 2 is 4p squared, and we're going to have 2p times 5 is plus 10p, and the middle term is minus 10p. Again, those cancel each other out, and negative 5 and 5 make negative 25, which is 4p squared minus 25. So what we're showing is conjugates. You can take a little shortcut and just multiply the first terms and the last terms, get your answer, because the middle terms will cancel each other out. And you're going to have a few problems doing that. And that's everything. You guys have a good one. You can end that.